everyone, welcome to another video of tech fundamentals. Today I'll be going through cardinality and if an index can actually slow down a query and not make it faster. So in this example I've created a table called people with name, age and sex. Name is Vacha50, age is an integer and sex is an enum M and F. I've used a procedure to fill in random data into the table and I've run it 8 million times. As you can see from this, that it has 8 million rows right now. And to see a sample set, what it looks like, it's a randomized string for the name, randomized integer for an age, and MLF for the sex. So, and you can see that I have no indexes right now except the primary key. So if I wanted to search for a name, I've picked this name out of the list. Right now you'll see that it takes around 1.4 seconds. I'll still run it a few more times to get an accurate picture. 1.3 and 1.3 again. So it takes around 1.3 something times without an index. I'll just note it down. No index, 1.3 seconds. I've done count star and not star here as I mentioned in my last video, because sometimes when the data would have been more than 1000, more than my limit number, the time wouldn't have been accurate because it would have stopped after looking for the first 1000 and would not have searched further. In this case it's not an issue because the count is anyways 3. So right now if I create an index on the name column using this command, it should technically speed up the query. As you'll see right now after creating the index. So this create index took 40 seconds and now if I try searching for the same name in a table, now it took us 0.089 seconds. I'll run it a few more times to get the baseline. 0.087, so I'll still put it as 0.09 seconds. So that's a huge improvement compared to 1.3 seconds. Now if I do the same thing for, let's say, sex, that right now if I just try searching for sex female, I will get the results of around 4 million rows in 1.5 seconds. So in this the count star helped. If I didn't have count star, it would have stopped after 1000 rows. So in this, without the index, it takes 1.5 seconds. So no index is 1.5 seconds. I'll still run it actually a few more times before confirming. 1.4 seconds and 1.5, so I'll just put it at 1.48 or something. 1.48 seconds it takes without an index. And I'll do the same thing again. I'll create an index for sex. So create an index took 11 seconds, and now if I try searching for all female rows, it gave me the same result in 0.689 seconds. So as you can see that it did improve the time, but not as much as from the first one. I'll run it a few more times again just to get the baseline. It should be around the same. Yeah, so the baseline is 0.68. So as you can see earlier in the name search, it went from 1.3 seconds in no index to 0.09 seconds, and this it went from 1.4 seconds to 0.68. So even though index helped, it didn't help that much. But let's try something else with this. So now let's say that I want to find all people above the age of, let's say, 60 in this. So if I run the same query again, I still have the index, and the result came in 0.88 seconds. There were no results, but it came in 0.88 seconds. I'll run it a few more times. 0.09 seconds and 0.89. So I'll still keep it. So even for the aged timing, it took me the same amount it took me to search for the name, and there was no difference because it was first searching on the name and then it was searching on the age. But if I try the same thing for sex, if I use the same filter of age greater than 60, let's see what the results are. This time, as you can see, it took me 17.9 seconds. I'll run it a few more times to get the baseline. But as you can see, without an index, just getting the sex took 1.4 seconds. With an index, it took 0.6 seconds. but just adding the age filter with an index on sex, the time went from 1 seconds to 19 seconds, and now it's 9 seconds. I'll run it one more time to get the baseline because there's a huge variation in this. Everyone should run queries multiple times to get the baseline, because it could be that your system's working more on one particular instance. So it's better to get it like 3-4 times at least, so you have a baseline number which would be accurate. So now these last two times it took me 9 seconds, which is still drastically more than the no index query, and it's still 9.4 seconds. So I'll put this as 9.5 seconds. But the strange thing is that with no index it took 1.4 seconds just to get the sex. Now let's say that maybe index is a problem. So if I drop the index, let's say if I drop the index sex IDS on people, let's see how much time this query takes again. So I drop the index, and now let's see. Now the query took me 1.6 seconds, which is surprising because I had an index on sex, which is still used in the where condition, not on the age condition, but it should have still helped and not actually degraded. So actually what has become is age without index is 1.6 seconds, and age with index on sex is 9.5 seconds. I'll run it a few more times again to get the baseline. 1.7, 1.7. So looking at these results, what does it mean? It means that actually having no index on sex would have been better in the longer run if we had queries which were using both sex and age together. Or what we could have done is the index on age would have been made more sense than sex. The reason for that being, I'll show you that. I'll put the index again on sex IDS. So the index is created again, and I'll show you the show index from people command. What it does is it shows you all the indexes and the cardinality. So as you can see, the primary index has a cardinality of around 7 million. The name index has a cardinality of 5.9 million. But the sex ID index has a cardinality of only 1. What does cardinality mean? Cardinality means the number of distinct rows available actually. So the primary index is 7.3, name has 5.9 unique, and sex has only 1, which is 1 plus 1 actually, not just 1. So it is only male and female. So what it means is, when you imagine a B tree, just think of breaking down a tree into two, one male side and one female side, but everything inside that is not actually ordered in any other way. It's just broken down into male and female. So if you're just looking for male and female, it did help a bit. The query did improve from 1.4 seconds to 0.68. But if you have other queries also associated with it, or you want other filters or other sorting, it will slow down drastically. The reason for that being, if you index a column, the results you get, and if you want to search through that using a non-indexed column, it becomes extremely slow. So there's a great article on IBM which does explain this. Low cardinality indexes are bad for performance in two major ways. First, they may cause erratic performance in the DB optimizer. DB optimizer is what decides actually how query should run. So in this instance, if the DB had actually gone through the ages first and then tried to look for the sex, it would still have been improved. It still would have worked better. But since I had an index on sex, it thought that maybe using an index would have been better. But it was wrong here, because even though sex has an index, but the cardinality was so low, it didn't help us in any way. Though age would have been more helpful in this, because age is more distinct. So I will share the link to this IBM article, and you can read through it since it's very interesting. But what it explains is that using indexes on very low cardinal number columns will be more harmful in the picture than actually using indexes correctly in more cardinal number. So sometimes if you have a column like sex, which is just M or F, you should not use an index, or what you should do is you should create a compound index. So if you know that you are creating an index on, let's say, sex and age, you should create a compound index. So I'll show you compound index also in this and how it would affect it. So let's say I create a compound index called sex and age, and let's see what the numbers come. Sex, age. The index is created. Let's try running the query again. This time it took 0.4 seconds, but I'll run it a few more times to get the baseline. 0.439, 0.438, 0.4. So as you can see, it's taking around 0.4 seconds. So as you can see, if we had an index on sex, it went from 1.4 seconds of having no index to 9.5 seconds. So it slowed down drastically. Without an index, it took 1.7 seconds. And using an index on the right two columns, a compound index, using both of them together, the time dropped drastically to 0.4 seconds. It's faster than even using just index on the sex column and just looking at the sex. As we can see from this, now if you look at the cardinality, now if you can see that we are using both of these together, so the cardinality is actually 1 and 201, so both of them together, it's not just one. So because it's trying to find all distinct values of sex and age, and it's combining both of them and creating hashes, so it's a more efficient way to search. So imagine earlier it was just a B tree having one side male, one side female, and now it's a B tree having distinct nodes having age, smaller ages, and the sex together, and creating many distinct nodes. I hope that helps and that clears out why indexes should not be used everywhere and why it's not a silver bullet to solve everything. You should always check when and where an index would actually help. Thank you guys. I'll talk to you on the next video.